You know, the phrase that a picture is worth 1,000 words? Well, a moving image is actually worth 10,000 words. If you were flying in the mitochondrion, it would be like flying over the Grand Canyon. It would be the most spectacular landscape you could imagine, because you have thousands upon thousands of proteins doing all of these amazing processes. And we also know that there are these big tubular extensions.
Molecular animation is the ability to bring proteins to life, bring molecules to life. It's really taking something that's too small for us to see and bringing it to life in a way that I think is really difficult to do using any other means. My name is Janet Iwasa, and I am a molecular animator.
The world of science is converging with the worlds of video games and film.
I think it's a gold rush right now, because a lot of the things that we have shown have never been shown. That perspective of, for example, viewing a motor protein moving along a microtubule has never been shown. There's biochemical data that supports it.
Building on decades of research and mountains of data, scientists and animators are now recreating in vivid and sometimes jaw-dropping detail the complex inner machinery of living cells.
So what is really the difference now with what we had before? I think now we can do these representations.
How proteins interact and how the processes that keep us alive actually work.
Before were drawings on a PowerPoint level, if you wish.
All of my other classmates were young guys.
The primary goal of my animations is to explain biology, to show students of biology what it is the science is all about, to strip away all the fancy language that scientists use to describe their work, and just to show people what is happening down at the microscopic scale. It is an accurate representation of, if you could see it, it would look something like this.
Other scientists are using these tools to bring the majesty of these invisible processes to the public.
We're all visual animals, let's face it.
Robert Liu, a cellular biologist at Harvard, heads up the BioVisions project, which 4 years ago created what some consider one of the most popular science videos of all time, a 3-minute visualization called The Inner Life of a Cell.
The only way I can describe it is to think of it in terms of cinematic terms. What we tried to do was to create the sensation of being there. We think a lot about the angle, such that it's like your perspective as if you were a microscopic entity that's actually sitting there in the environment experiencing what's happening.
The sequel to The Inner Life of a Cell, a new animation called Powering the Cell, Mitochondria, was released online this October. Though produced for medical students, it has generated wide public interest. The video takes viewers inside the complex molecules that convert food into energy.
We need to communicate to the public what's happening at the molecular level, at the cellular level, at the whole organism, at the whole ecosystem level, what is happening with the living world. And I think visualization is going to be absolutely fundamental for that.